So our other two fossil fuels are oil and natural gas. And while coal is carbon and impurities, natural gas and oil are hydrocarbons. And so natural gas consists of molecules that are four or less carbon atoms, whereas oil has five or more carbon atoms. So a hydrocarbon being a carbon that's saturated with hydrogen. Um, Oil and natural gas migrate upward. So remember that they're formed from plant and animal matter that are buried, and over millions of years, with time and pressure and heat, end up becoming oil and gas. And so a lot of times they're found together. And so they ultimately will, from down below, they will migrate upwards until they end up hitting some impervious surface of rock. Um, in using oil and natural gas, there is the issue with combustion. So we have a large amount of carbon dioxide going out into the atmosphere, a lot of other pollutants, such as, you know, nitric oxides like NOx that are going out into the atmosphere as well. So there are all kinds of pollutants that are going out into the atmosphere. And while natural gas is much cleaner burning fuel than oil, it still does have some environmental implications because it does emit carbon dioxide, just not as much, and also not as many other pollutants. The production of oil and natural gas is very disturbing to the land in which that we're drilling. And so when you drill into the land, you're obviously disturbing the land there and the habitat of the organisms that live there. Once we do drill it and pump it out, we have to transport it. And so when you transport it, you always have um, the the worry about spills, so both oil and natural gas. And so, of course, we worry about spills on terrestrial ecosystems, but in aquatic systems, because it's all connected through the water, it's even a tougher thing there. We talked about the Exxon Valdez oil spill and the Deepwater Horizon oil spill. And so we'll talk about the Deepwater Horizon oil spill in a little bit. But, since we already went over it, not too much. So petroleum or oil is naturally occurring. It's a flammable liquid that's found in the rock, and it's a mixture of hydrocarbons. And so we take that petroleum or crude oil and we distill it. So we heat it up and then we extract off at different temperatures into different things, such as gasoline, diesel, jet fuel. All of these things are petroleum based that we have extracted from um, distilling crude oil. And it is deeply buried, um, at deeply buried reservoirs from the formation of. Oh, I'm really messing this up. I'm so sorry. I'm losing my words. But I'm not going to start over because I'm too far into this thing. I'm going to keep going. Okay. So crude oil is deeply buried, and it's formed from organic material from plants and animals. And the reason why they're deeply buried is because it was so long ago. And so they're covered over really, really deep with lots and lots of pressure, high temperatures for millions and millions of years. And so, like I said before, they are found together because they're really stemming from the same thing. So again, here's like a picture of oil extraction and an oil rig. You can read about it a little bit. You don't have to know too much about it. Really, just that you have to drill really deep into the earth and then ultimately pump it out. And so, like I said, you have to pump it out. So there's primary oil recovery. You're drilling a well and pumping it out. That flows by gravity into the well. Secondary oil recovery is where we're pumping it out, but in order to get it into the well, you're injecting water into surrounding wells to force the oil because obviously it's hydrophobic. That oil will be repelled and pushed into the well in which you want to pump it out of. And finally, the tertiary oil recovery. You are going to inject steam into the well to kind of loosen up that oil a little bit to get it out easier. And so the average yields are not very high, max like 50%. And at that point, it becomes super expensive to extract more. So we kind of usually leave it until we introduce, fracking and whatnot. Drilling for oil is associated with lots of environmental issues. There can be groundwater contamination, destruction of land, obviously, and then pollution from oil spills. So deep water drilling is obviously not drilling on land; it's drill in water, and we have the technology now, and so we can explore and extract from deeper and deeper water. And so this is where we are really starting to put our efforts into deep water drilling. In the Gulf of Mexico, there are huge numbers of people that are employed by the oil companies down around the Gulf of Mexico. It produces billions of dollars. It's economically very savvy because right, the world runs on oil. So, it is very valuable in that respect. But it can lead to something like the Deepwater Horizon oil spill, which we talked about before, like I said. And so there was a blowout, it caused a massive explosion, and ultimately you ended up with this flow of oil that they could not stop. And so they put booms around it and they tried to recover as much oil as they could. And here's just some more information about stopping the flow. People couldn't go down there. It all had to be done by ROVs because it is just too deep for people to be able to be down there. So, those are the challenges of deep water drilling, even though it is economically, positive at this point in our economy. Here's a little bit about refining crude oil. So, like I said, it is distilled. So we heat it up and then we extract off at different temperatures. Um, and so you have gas, right? You have like your propane that you would burn. Here is right, gasoline that you have for your car, jet fuel, oil that you heat your house with, right? So all of these things are made from crude oil. Proven oil reserves, well, you know, they are definitely decreasing, and there are definitely some reserves that we have not found, but we are using them faster than we're able to recover them. And so here is a little depiction of where the current oil and gas reserves that we know about are. So again, right around the Gulf of Mexico is a big point. Here up in Alaska, as well, is a big concern of ours here in the United States. And of course, the Middle East, which is also a huge source of oil. And here is a little bit closer look at North American oil and gas reserves. How much oil is left? Well, anywhere from 50 to 100 years, we could deplete our oil for, to about 80%. Like we're using it fast. So, that's why we call it a non-renewable resource because it is not able to be recovered within our lifetime.